Chapter 11 dealt with finding the surface area and volumes of three-dimensional figures, space figures we call them. Okay, along with this chapter came a whole bunch of different formulas. Now they're all on your formula sheet, so we're not going to list them all out here. We'll kind of point them out as we use them as we go through the chapter. Okay, so here we go with that. Problem 1 says Bobby is going to construct an aquarium with the dimensions shown. If he's going to cover all sides with glass except the top, how many square feet of glass will be needed? Okay, the first thing you want to do when you come across a three-dimensional figure is decide, are we talking about volume or surface area? Okay, we want to know the square feet of glass to cover the outsides. Okay, not how much this aquarium is going to hold. Okay, so here we're talking about surface area. Okay, the aquarium looks like it's going to take on the shape of a prism. Okay, we said that was a 3D figure with two parallel bases and all other sides rectangles. Okay, we can think of any set of sides we want as the bases. Okay, and the formula we had for the surface area of a prism is we said that SA is equal to P as in perimeter of the base times H as in height of the prism, okay, plus 2B. 2B as an area of the base. Okay, so let's select a side for the base, and I'm going to select the bottom of this prism as the base. Okay, and the reason I'm going to do that is that's going to kind of help me with this problem solving part easily here. We're going to cover everything except for the top with glass. Okay, so if my bottom and top count as my bases, what I can do just for that piece that we're going to leave out is just add in one base instead of two bases. Okay, so again, since we're leaving the top open, we'll just have a single base here. Okay, so our surface area then is going to be equal to perimeter of our base, which will be 5 plus 10 plus 5 plus 10. Okay, times the height of the prism, so times 4. And the height will be the distance between the two bases, between the sides we select as the bases. Okay, and then plus B plus the area of the base. Again, we can use any of the sides of this prism as the base, except for once I pick a side for the perimeter of the base, I need to use that same side for the area of the base. Okay, so to find the area of the rectangle at the bottom, we'll just say plus 5 times 10. And we can plug that all in one step. Okay, if you're going to do that, be careful with the calculator for parentheses. Otherwise, we can take each of these a piece at a time. Anyways, when I plug it in, I get 170 feet squared, okay, which is option C here. And then I bet that option D, okay, which is an additional 50, another base, that would be if we included two bases. Option B would just be the lateral area without the base. Okay, so do make sure before you circle an answer for this type of problem that you have everything you need, you don't have any extra stuff, because that's what these extra answers are going to be made up of. Okay, problem 2 asks, how much paper is needed to make the drinking cup below? Okay, and our cup's in the shape of a cone. And we say, how much paper do we need? We're not talking about how much liquid or material what it holds. We're not talking volume. Again, here we're talking about finding a surface area. Okay, formula for the surface area of a cone we said was equal to 1/2. Okay, times the perimeter of the base. In other words, times the circumference of the cone. So 2 times pi times radius. That's just the circumference of our circle. Okay, times the slant height, which we usually call a L here. And then plus B, the area of the base. Okay, now once again, we're not going to include the area of the base on top. If the top was closed, we couldn't drink out of the cup, so we're going to cancel that out. And what we're looking for then is just what we call the lateral area, the area along the sides of the cone. Okay, so I could say that SA is equal to, now a lot of formula sheets will actually cancel out the 2's. So for example, the MCA formula sheet says it's just equal to pi times radius times the slant height. Okay, since these 2's cancel out. So we have the pi times the radius. Now it looks like it's giving us the diameter of that circle all the way across. Okay, meaning the radius will be just half of that, 3. So times 3. Okay, times the slant height. Now remember, with our cones, with our pyramids, we had 2 types of height. There's a height directly down the middle at a right angle. We call that the actual height. And then we also had the slant height along the side. That's what we abbreviated with the lowercase cursive l. Okay, so here we're given the slant height actually. So we'll just multiply by 12. Okay, and again, we're leaving the base out because the base is going to be open. So all we need to do is multiply pi times 3 times 12. And doing that, I end up with 113.1, we could round to, inches squared. Sorry, we should mean centimeters squared. These are in terms of inches. Typo we'll have to fix. Okay, so that's going to round to the nearest whole centimeter squared. 313 centimeters squared. All right, here's a fun one. Problem 3 says Tommy drew this diagram of his backyard to help him decide how many cubic feet of topsoil to buy. The backyard contains a 30-foot by 50-foot swimming pool and a hot tub with a diameter of 10 feet. If he wants to cover the entire yard with 6 inches of soil to the nearest foot, how many cubic feet does he need to buy? Okay, so we're talking about a volume problem. Since we're looking for cubic feet, that's going to be a volume. And the basic plan of attack for this problem is we're going to say that the volume is going to be equal to the area of the backyard, okay, times the 6 inches high that we're going to stack the soil. Okay, so in other words, times 0.5. So really the tricky part for this problem is going to be figuring out what the area of the backyard is. Okay, for the area of the backyard, looks like we have a rectangle. Okay, we're going to subtract out a circle and then another rectangle from that. So we'll start off with the larger rectangle. It just has a base of 125 and a height of 75. Okay, which gives me 9,375 when I plug all that in. Okay, so for the total area, we'll have 9,375. Then we're going to subtract out the smaller rectangle. Okay, it says that it has dimensions of 30 feet by 50 feet. Okay, that's the swimming pool. So 30 times 50 will give me 1,500. Okay, so 9,375 minus 1,500. And then also minus the area of the swimming pool. Sorry, the hot tub. It says we have a hot tub with a diameter of 10 feet. Okay, meaning its radius is 5 feet. So area is going to be equal to pi times radius squared. So pi times 5 squared. And when I multiply that out, I end up with 78.5 feet. Okay, so here we'll go minus an additional 78.5. Okay, subtracting those, I'm ending up with 7,796.5 feet. Okay, suppose we should say feet squared as we run out of room. Okay, so for my volume then, what we'll do is we'll take that area and then multiply it by the ½ inch of soil we're going to cover the area with. And when I do that, I end up with 3,898.25 feet to the third because we're talking volume. Okay, so it looks like option B, 3,898 cubic feet. Problem 4 just asks, what's the volume of the pyramid? Okay, we're talking volume and we're talking pyramid. Okay, that's another formula that's going to be on your formula sheet. Volume for a pyramid, we said, is just 1/3, okay, times big B as in area of the base, okay, times H as in height of the pyramid. Again, we actually have everything we need for this. We want to just double check and make sure you're able to, execute these formulas. This is one that's going to show up on a lot of standardized tests coming up. So we have the third. Now for big B, the area of the base, we need to figure out the area of the square at the bottom. Okay, so that'd be 7 squared, we could say, for 7 times 7. And then times H, the height. Okay, here just watch for, make sure we have the right height. Yep, it looks like this 8 feet is the correct height. Remember, our other height for a pyramid is the slant height. If we didn't have the height, we'd have to solve for it using the slant height. But we have the right height, so we'll just say 8. Okay, multiply all that through. And I'm ending up with 130.6 repeating. Okay, or in other words, 130 2/3 feet. Oops, typo, that should be cubed. Okay, so we can recognize that a 0.6 repeating is going to be that 2/3. And the last question from this section, it says a medium-sized box can hold 55 t-shirts. If the dimensions of a jumbo box are 3 times that of the medium box, how many t-shirts can the jumbo box hold? Okay, here the thing to recognize is right off the bat we're talking about a volume. Okay, the number of t-shirts or the number of items something can hold is based on the volume, how much space is in the box. Okay, and again, we saw this with our area section. It'd be tempting just to take the 55, okay, times 3 for the 3 times the size dimensions. That gives us 165 t-shirts. Okay, again, like I said, it'd be tempting to do that. That's actually not the answer for this one. It's actually not that simple. Okay, remember, just like with areas, our scale factors are different for volumes. So if I have the scale factor of the sides, okay, and let's say that scale factor is A divided by B. The scale factor for the area, so if we want to find the surface area, would be A squared over B squared. Okay, and the scale factor for the volume then would actually be A to the 3rd over B to the 3rd. Okay, again, we're talking about volume, so that's what we're going to use. So our scale factor for the side lengths is 3 times the size, meaning the volume will be 3 cubed or 27 times the size. Okay, so to get this answer, we'll take the 55, we'll multiply it by the 3 to the 3rd, okay, in other words 27. And when I do that, I end up with 1,485 t-shirts. Okay, so we get to hold a lot more when we account for that the volume gets 3 times as big.